Hello students, have you ever looked at an organic chemistry problem and felt your brain shut down? Don't worry, you're in the right place. At Organic Chemverse, I teach you how to approach and solve questions with the proper reasoning, which builds the confidence you need to tackle even the most challenging problems easily. So let's get started with today's question. There is an organic compound M and it has the following data. The molecular weight is given for M, that is 149, and it contains 3 elements. We don't know what are the 3 elements. Obviously, it has to be carbon and hydrogen as it is organic compound. We don't know the third element. It could be oxygen, nitrogen, halogen. So the information might be there in the further statement. So let's read all the statements. It can rotate plane polarized light. That means it is chiral. It has chiral carbon. M on oxidation with hot alkaline KMnO₄ produces benzoic acid. That means there is a benzene ring in the molecule. M can be prepared by trading carbonyl compound with methylamine followed by sodium borohydride. That means it is a secondary amine. How do we know that? Whenever a carbonyl compound reacts with methylamine followed by sodium borohydride, which is also called as a reductive amination, right? So you are adding the amine group, right? So methyl amination in this case. So it has to form a secondary amine. So that is the other information we got. Now, what is the question here? The actual question is you are supposed to write the possible structures for M excluding stereoisomers because the molecule here is chiral. So we need to exclude the stereoisomers and find how many structures are possible for M. The main statement which will help you to solve this question is the fourth statement. It says that when a carbonyl compound, so we know it can be aromatic in nature, right? So let's write down that, right? And it is having a benzylic hydrogen because it is undergoing, say, oxidation with KMnO₄, right? Or even the carbonyl can be directly attached. And how many carbons we need? So in order to match this mass, okay, say let's assume we take ethyl group here like this. You can try for methyl, ethyl, hydrogen, etc. Okay, say let's assume I am taking ethyl here, right? So then it is treated with methylamine, also known as methanamine. What happens? First, it will undergo condensation. That means the hydrogen, oxygen will be eliminated and you are going to get an imine like this. All right. Now, with sodium borohydride, we know that we can reduce the carbon and nitrogen double bond. So, it is undergoing reduction, right? So, look at this. There is a NHCH3 here and you have added hydrogen over here and then CH2CH3. The product formed is something like this, which might be M. Let's verify that, okay? How many carbons we have here? 6, 7, 8, 9, 10. There are 10 carbons. Its mass is 12. Therefore, for one carbon I am talking, so it will be 120. There is one nitrogen, right? So for one nitrogen it is 14. How many hydrogens do we have here? 4, 5, right? Here 5, 10. And students, don't forget the hydrogens here. Many students, they tend to forget these hydrogens. So please don't do that. So we have 5 here, 5 here, 10, 11, 12 and here 3, 15. Now count this. You are getting 149 exactly. Say if you are not getting 149, you keep adding either carbon, hydrogen here and then make sure that you are going to get 149 as its mass. Okay. So now this could be our product M, but as I told you, let's verify the given statements with this. Okay. The first statement, anyway, it's verified. Now, is it chiral? Look for the carbon attached to 4 different groups. A carbon attached to nitrogen, hydrogen, ethyl and phenyl. Yes, it is chiral. Okay, so this is also true. M on oxidation with hot alkaline KMnO₄. Because of this benzylic hydrogen, yes, it will form benzoic acid. So this is also true. Now, M can be prepared, yeah, anyway, that's how we started, right? So this is also true. So this is our M structure, but they're saying what are the other possible structures. That means what? I have to write isomers of this, right? I have to write isomers of this, which will give a product, and it should also obey all these statements. So for that, what I'll do is I'll write the possible structures for this molecule. So let's write down for benzene, right? Instead of carbonyl taking here, what I'll do is I'll take carbonyl over here like this. When I take carbonyl over here, the methyl amination will happen here. So that means what? There is NHCH3, right? And the hydrogen will add over here like this. Now again I have to check all the statements. Anyway, the first one will be true because I am writing isomer of this, right? So is it having chiral carbon? Yes, this is the chiral carbon. And because of the benzylic hydrogen, it will form benzoic acid, right? And anyway, we have started from fourth statement. So that is also true. So far I got 1 and 2 structures. So let's write down. What if, right, I take the carbonyl here, okay? So that means what? CH2, here instead of carbon oxygen double bond, that means aldehyde, okay? I'll take like this, NHCH3, okay? Hydrogen and hydrogen. Yeah, all the statements will be obeyed except for the chirality. There is no chiral carbon here, therefore this cannot be the structure. What else I can write? Can we change the position over here like this? Okay, what if I write CH3 here and then H here, and then here if I take aldehyde? Yes, that is possible. So here you are getting NHCH3 and then there is H and then there is H. Although we don't have a chiral carbon here, we do have chiral carbon over here, isn't it? Right? So this is the other possibilities. So what are the possible M structures we have written so far? 1, 2, 3. Okay. So if you want to try some other structures, definitely you can go ahead and try. But for me, these are the 3 structures I got for M. The number of possible structure for M here is 3. I hope you have understood this question and the explanation, and if you have any queries with respect to this, you can comment your queries in the comment section. Thank you for watching this video. Until next time.